Okay, clause A means that neither I nor C is in between L and R. So yep, L and R here, I and C are both larger. Also in this case, L and R here, and then I is less than and C is larger, or the other way around. And L and R here, and I and C are less than both. So they're never in between L and R. That is clause A. Now we have clause B, where I is in between L and R, but C is not. That means that C is either on the right or on the left side. Clause C is where C is in the middle of L and R, but I is not. Clause D is where I and C are in the middle of L and R, and I is on the left. And clause E is the same, but then if I is on the right of C, but both are in between. The classifier must produce numbers that are different for each clause. So it's not allowed that any number in a given clause also occurs in a different clause. Now, in this case, all numbers are different. Therefore, well, there are never duplicates. And the question is it possible to do this with 4 comparisons where each comparison is simply a Boolean, basically comparing 2 variables. So for example, if we remove this, there are at most 5 possibilities, right? I mean, we have 4 variables, so we have in total 4 times 3 is 12, but we don't care about ordering, so let's make that 6, and we don't care about left and right to be compared, because left is always less than R, which then leaves us with 5, the maximum of 5 comparisons, which I'm using all 5 are being used here. And if we just compare 2 variables and do anything more fancy, and we just multiply them with 1 and 2 and 4, 8 and 16, then of course we get to see the different values depending on this. So in this case, they are definitely all different. Now I'm going to comment out this one and then see if we still have a solution. Probably not. So now we have a 0 in clause B and a 0 in clause A. So this failed. And also the 20 is a duplicate in different clauses. And that's it, I think. Oh, the 28 as well. So we definitely need that compare. And well, very dumb. We're just going to comment out the next one. Now I'm seeing a 5 in clause E and in C. So that doesn't work. We see other duplicates. Yep, 29 is in A and B. 1 is in A and B. So it doesn't look good. No, 1 is in E and B. And 3 is in C and A. So 16 is in C and A. No deal. I would say it's not possible at this point. Seven is in two classes. 20 is also in two classes. 21 is in two different classes. Complete failure again. And then of course the last one will definitely also not work. I already know that it goes wrong. D and E will get the same value. So almost, but unfortunately these two must be separated as well. Yeah, that doesn't say much, because this way I can produce 32 different values, and I only need 5 different values. Theoretically, we could do this with 3 Boolean expressions. But yeah, if we would figure out those Boolean expressions, and those Boolean expressions will also take up CPU. Might as well do this. I don't know. A comparison is probably not very expensive, is it? Is it like equally expensive as the shift? It's like 1, 2, 3, 4 shifts, 5 comparisons, and 4 additions. But at least it's branch free. Can't you negate these things? Don't ask why. Now, you must note that I less than L plus I less than R. So this is either is a 0, 1 or 2, depending on if I is in between R and L or not, or completely on the left or on the right. So that would be three things, three possibilities, and then here we have the same thing. But I must be able to make a distinction between both, and they have now 0, 1 or 2. So I'm no longer able to distinguish between the 0 case, am I? Maybe we can solve this with that. I'm having the feeling that if I just multiply this sum with something, and this sum as well, then it should work, and then probably something large like 4 should do. And then here we have 2 is not enough, so 4 then. And then we have the maximum value now becomes 2 plus 8 is 10, so let's do this one, I don't know, probably 16. I think I got rid of 2 multiplications this way. See what that gives. This gives 5 is unique, 21 is unique, 22 does not happen anywhere else, 4 doesn't happen anywhere else, 9 doesn't, 17 doesn't. So yeah, that works as well. Now the 26 is pretty big. Maybe you can get rid of the 16 somehow. Let's just try something else. Actually, if you just want to, well, I could multiply it by 3, but I like, of course, the I don't know, it feels like cheaper to multiply with 4 than with 3. Try multiplying with 8 here. It probably doesn't work, but you never know. That does work. 5 doesn't occur anywhere. 13 does not occur anywhere. 14, nope. 4 not, 9 not, no. That works. And now the biggest value is 18. This is pretty reasonable. Yeah, that would happen when just everything is true. So this one is true, that one is true. This is 4 times 2. And we have 10 already, and then plus 8. Still not happy with the 8 though. What about a negative thing? Then we could become, probably can become negative. But maybe it gets more compact. You see, the last term is only absolutely only relevant when we need to distinguish between the class D and E. In D2, so this is 8 apart now. But that 8 also makes this one super big. I would like to drop below 16 really. And I think we have a 5 here, so why not keep the 5 and then simply add, yeah, just 1. I mean, there's no 6 here. We just add 1. Now, this would become a 6. I don't know what that will give me, but I'm gonna try it. That would be even better, right? That would be really awesome. I think it actually works. Holy shit. 5 is unique, 6 is unique, 7 is unique, 4 is unique, 9 is unique, 2 is unique. Dude, we nailed it. That's pretty perfect. I don't think you can get it any more perfect than this. So at least I halved my table now, even less. I went from 32 to size of 12. Yep, I think I'm just going to stick with this one. Now, suppose I want to have these numbers as output. Why not? What kind of map do I need then? Or do I not want a map and I can do it differently? I don't think you can do it differently. I'm afraid a lookup is the best thing. The table is now very small. Can make an unsigned char table. With the size of 12 now. And then everything is class A except when it is not, meaning 2 and 9 are B. 2, 3, 4, 5, 6, 7, 8, 9. And 4 and 7 are C. 1, 2, 3, 4. 5, 6, 7. And then 6 is D and 5 is E. Shall I just turn them around? Can I do that? Let me try that. Doesn't matter much, but it's going to change everything, isn't it? Still 11 is the largest. Oh, no, that doesn't work. Oh, that doesn't work. Yeah, interesting. Interesting and strange. Nou ja, okay, why not? So see, the class D is 6. So 1, 2, 3, 4, 5, 6. That was class D, so that is 3. And then 5 is class, the other class. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, all 12 cases have a distinct value here. Completely turned ChatGPT. Completely turned it. This is wrong. It's just not even correct. ChatGPT in verifying. Yeah, right. It can't even verify its own solutions, so. What a bullshit. What a bullshit. It's just really, really random shit. E has only a single case, so how can it have 3 different values? A, what? No, what a bullshit. Man, okay. Deep. What a bullshit. Anyway. It said class A had only one value. That's what it said, right? You see. 6 cases. Every case has a different value. Therefore, 6 different values, and not just one. And then class E gave 3 values. Well, there's only one case in class E. Yeah. Const expression, it seems kind of silly. Huh? That's not what I want. Just make it a static. And so our classes have been determined. Right, now back to the actual program. What am I saying? I've been busy. Algorithm. Nah. I need to be in class, I think. Like VI gradient descent. Class. Style. Style. Scale. Which will make that private as well. Git public. Put this outside a class. Outside a function, I mean. Make it a static const expression so I don't have to define it in a scale.cxx file, which I don't have. If it works, it works. So really, I don't feel like making a new file just for that one. I forgot. LICR. LS less than I. That's I between L and R. Which clause is that? I between L and R is just clause 1. Okay. This I don't know yet. This is clause. This is C between L and R. That would be 2. And this is I is less than C. I less than C. That's clause 3. 4. Now this one should be actually I'm not sure that this works. It's probably not working. Is it? They're equal, then they're not less than. So basically, in this case, C is less than I is false. Which am I comparing? I compare I, so this is false then. So it behaves as if C is less than I. Which means that C is less than I, so it behaves like this one. And that gives me 0, so then this one will also give 0. And here we have an equal as well, though this one behaves like call it again. Should I C less than I, right? Yep. This behaves like C is less than I. C is less than I. Or to return 0, so therefore this one also. And here we have something. Now C will behave as this behaves like C is less than I, which is this one. So that would return a 4. But I don't want to do this, I want to do that. There. But okay, if this is the case, so if C equals I, and instead of class 2 I would use class 4, then what you really get with the WA means a weighted average around the thing in the middle. So we would get the weighted average around C, where C and I are equal. That would just return L minus C, the distance between L and C, which is equal to this one if L and R are at the same distance, or if L or R are at C. So it's usable, you know, like I might as well do this one, I think. It's a super special case anyway. So 2. However, classify returns 4. But that is usable too for this case. Yeah, it's just that it's kind of ignoring the value of R in that case. Slightly annoying, I have to admit. That is actually pretty annoying. It's not good. I don't want that. I do not really want that. I would say I could make an offset based on if C equals I, which then probably will ruin this. So never mind. I don't know what to do. Introduce just not call classify, I guess, if C equals I. It's not. I don't think it's usable. Okay, let's write WA. Yeah, I'm not sure it makes a difference, but let's do m minus x. I mean, I know that it is positive. And y minus m is positive and y minus x is positive. Yeah. LICR. What the hell? I'm going to make a, sorry, I'm just going to make a copy here. Probably resulting in the same assembly, but still. So I'm gonna have an L. And then R. Class 1 is LIR. And then, okay, I is the inflection point. Result is the weighted average of. just use CP instead of M. So in case 1, I want to use L and R, but I want to use CP. I'm going to use the inflection point for CP. And in case 2, we don't want to do anything. And in case 3, we'll want to replace L with the inflection point. And in case 4, I want to replace R with the inflection points. Which then makes you feel that maybe I should just use an array here. Then I don't even need a switch. Okay, choose an array. So now I want to put I at the end, I think, because then I won't use, I don't know, and I just use a more compact memory region. So now you have LCR and I at the end, and then of course numbered in that order. That still should work now. So L is less than R, like, yeah, obviously, but these things are going to be changed, so it's not really L and R anymore. That's why I want to have a test. So these are indexes, right? So the CI index means we get the C thing, the second one of the array. And then we want to simply execute this if the returned value is, let's say, not an array element. So I want to swap the values of the classes as well. This now should be 4, I think. So class A becomes 4. In fact, So here we have the C. Well, let's just fill it in the width like it is now. Then CP is now LCRCI. That should not do anything, and this is left, so that would be left index and the right index. And the left index, I mean the indexes are respectively so these LCRI so L is the first one, C is the second one, LCR I. And I is not being used, so I mean here we pass again the same array. So the fourth argument is not used in weighted average, so I can just override here. I could override it. It doesn't make much sense, but I can override the inflection point with the inflection point. Well, it's already there, but who cares? So that doesn't do anything. And I want now to swap. I want to make, okay, so I want to make 3 must become 0. 1 must become 1. 4 must become 2. 2 must become 3. And 0 must become 4 then. For the class result. So that's the result of classifier. Substitute, let's see, we have to rotate stuff. Yeah, I just started with the first one, I guess. So let's replace 3 with x, 0. And then replace 1 must stay 1. Wait, I replaced 3 now, so I can now do this one. So 2 becomes 3. And then 4 becomes 2. And 0 becomes 4. And then 3 becomes 0, but that's not a z. So substitute z becomes 0. Yeah, I feel a bit insecure about this, so let's undo this. Copy this, redo it, paste the previous thing, and then see if it worked. So 0 became 4, 1 stayed the same, 0 became 4, 2 became 3, 4 became 2, 3 became 0, 2 became 3, 0 became 4, 1 stayed the same, and 0 became 4. So that is actually correct. Which means I have to change this comment as well. Zero became 4. And 1 stayed the same, and 2 became 3. And 3 became 0. And 4 became 2. And now the trick here is that this class corresponds with the index that I want to change with the inflection point. For example, 1 means it's now, what was it? LCRI, yeah? So 1 means C. So instead of LCR, we use LIR. So the 1 is the thing in the middle. And then 3 means the I is replaced, so there's nothing is replaced, it just stays LCR. 0 means the first one is replaced, and 2 means the second one is replaced with the inflection point. And that then we can do here. Three became 0. 1 stayed the same. 4 became 2. 2 became 3. And 0 became 4. Then we did all the replacements. And now Li equals 0, and Ci equals 1, and Ri equals 2, and I equals 3. So all of these can now be replaced with class. So I can do if class equals 4, result is that, else and then the result is weighted average, after which I don't need to do this anymore. Yeah, okay. And then here I have to do something nasty like if type equals something and class is something, then class becomes something else. Which then would take care of this case. So it return 2. And in which case class should have been 3. And that is for type equal to the inflection point. Look at point type, inflection point. Right, I didn't assign the inflection point yet, or even define it. I'm only needing it here in one place. No, I need it here as well. Still, I could just... I already have it here. I could assign it from LCRI, LI, II, I mean. And then it would just be here. I could calculate it here maybe. How do I get it anyway? Probably doesn't make much sense to cache it. And then again, does it even make sense to cache the critical point? Or is this being used then? UCP. Let's debug code. Okay, it's used again there. Yeah, I don't want to calculate it again, so maybe this is all inside the same function. It's assignment. No, it's a previous value. I need to cache that. Thing is that I'm assigning cubic here, and I'm not assigning critical point yet. It's really strange, isn't it? So if not local extreme, then cubic has been changed below this point. There's no return, so we always get there. Otherwise cubic is not changed, so I shouldn't care too much about that case. So if not local extreme, then the cubic was changed, but critical point was not set yet. However, it's now stored in this one. And then here I set it because, yeah, returning here. And otherwise I'm using the old critical point here. And I'm using the old critical point here. And then local extreme was not interesting. And in the case of the not local extreme, it's assigned. So it's just a yeah, no, okay. Maybe instead I should just keep the old critical point in a variable called old critical point, and then assign the critical point directly, the new one. So this works as well, it seems. And then by the time we call calculate value in this function, which is done in just one place, calculate value, what's done there, and it's also done here. Okay, that would see the initialization. Yeah, then the critical point has been assigned. Anyway, I don't see a reason to cache the inflection point as well, because we are calling calculate value after critical point variable has been updated here, and here as well, obviously. Either updated or it should not have been changed, because this is a local extreme. Right, so getting here, I want to calculate the inflection point. Now let's just use the place on the stack that I created here instead of a new variable. And then here I want to calculate the inflection point. That would be problematic unless I have access to the cubic. And this is inside somewhere. Yeah, just cubic. Hopefully the cubic polynomial gives me an inflection point already. It doesn't. Well, we'll just have to add it in. So that's the point where the second derivative is 0. So, well, if we set this to 0, and it's actually the x coordinates. We're not doing more often here something with like x, delta x. I thought I had a vertex x. No, that was more something with the parabola, I guess. So yeah, set this to 0 and then return x means minus this divided by that. So if this is a parabola or a straight line, that won't work. Yeah, that's not nice, of course. It's totally not nice, because sometimes it could be a parabola. Like almost. Minus that. So multiply that, say, with that and that. That, yeah. That looks correct. Cubic inflection point. No. Maybe I should just type it, because it has been a while. Oh. That's a new one. Yeah, we are working kind of like outside what I'm graphing. So I don't have a visual feedback here for this. 2, 2, 2. No, we're still here. Still inside the graph, it seems. W minus 7. And current is what? These are exactly the same. Yeah, I would say this should be equal, right? Because, I mean, current is... Oh, shit. Okay, we'll start over. So we are here, and then the cubic, this cubic, is based on that point. It's just going through it. And therefore the value of it, which is 1800 something, should be equal to, of the sample I mean, should be equal to the one of the cubic. I completely agree with the assert. So what the hell goes wrong then? And what would it go wrong after I change my scale? Didn't change anything else. Let's highlight this value up till that point. See where it happens first. Extremes out. That would be some cubic, new critical point. And then critical point is still that. The minimum is there. We make 0.5 at that point. Turn it. Get a sample value with 1872. Let's remember this, 1872.35. Add that to the history, add that to the approximation. So now it is part of that. So this cubic should fit, should return this value for that W value. Okay, so this value, we saw that before, that should be the A35, yeah, 1872.35. And apparently it is not exactly equal to the value of the cubic, which of course GDB will refuse to compile. Show, yep. No. No, not too bad. Well, they are pretty close, but not down to 6 digits. Why not? Why not? It's a good question. And moreover, why not now? What cubic are we talking about? I'm having a new cubic here. And we're having this cubic. It would already have been copied, I would say. Looks pretty much the same. So whatever's passed as new cubic here is the cubic. And that comes from approximation, of course. That is cubic. And that should be, let's see, where is my approximation? Skill update skill. Entering approximation add. So we're passing this W value and then the result is this cubic. And this add should be current. So if we go up, update approximation. Where's my add? Update approximation. Yeah. So literally adding current of the history. No, it seems that 6 digits is asked too much of my cubic fitting. It's just not that accurate, surprisingly. It kind of surprises me, really. Yeah, I don't know. I don't like it. I wouldn't think 6 digits is too much to ask for something that is a precision of 15 to 20. I'll just give in 1 digit, see if that helps. Not something else, but still. We really shouldn't change our mind about the direction. Oh, how come, Post Bunny? How come? Region right. Left and right. We switch from left to right. Seriously. You know what? I think that it's just not terminating. It's not terminating. We get close to the minimum, and normally we would, like, way before we really get into the minimum, we would just already say, okay, we're there. But if my scale change fails and it returns a scale of 0, which definitely looks like it this way, it's just no scale, then we will try to infinitely precise determine this point, and that infinitely precise attempt is then doomed. That's why we see all kinds of artifacts which which are bugs anyway, but I didn't see them before. So apparently it is possible to change the idea of going left or right, and the assert is false, but I have to understand why it happens. What is the exact reason that one moment we think we have to go to the right and the next moment you have to go to the left? It's probably because the size of the region is just close to 0. There's no in between anymore. Floating point round off errors. Yeah, that might be it. So we're trying to be so precise that we get noise from the floating point round off errors, and therefore jitter between left and right. That would kind of explain this. That's a hypothesis, which means that the scale is should be returning 0, or at the very least. We are not finding a minimum anymore. So we have been trying to this is also red herring. Is that the right expression? I think we have been calling this operator with that value for several times now, maybe, or at least twice, or maybe 3 times. It's highlighted 22, and that's the second time. That's different. Only the second time. So this step is already pretty small. Apparently not small enough. And then here we have this. I've never seen a step this small, and then not thinking that we reached the end. And then here we have problems drawing it even. I think in the neighborhood of this, where the absolute step is very small, we should have detected that we just reached minimum. That's my guess. So here. So, and this doesn't fire anymore, I guess, because scale value is 0. And that's the only thing I changed. So let's set a breakpoint here, 750, on an absolute step less than a millionth. And then see what happens. Oh, and I've got where that was then. My algorithm CXX 750. Fuck, I hate it. Then I type in the window, and then of course I can't run it anymore. And I have to start over. 750. Click here. Condition 1. And the absolute step is less than 1 millionth. Continue. There we are. Print approximation scale. The value is negative. Well, that would help as well. Yep, okay, we got it. The negative value is, the value should be positive, so probably everything breaks down because it is negative. Did I type L minus R? Did I do that? No, I didn't. Yeah, I did. L minus R. R minus L. Ding, 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 ding. That's better. So then bang, we are there, and immediately we did find that it is a minimum. I guess I can just continue until we get 14 here. Yep, 14 is there. And then the difference that I was looking for is we jump to 15, and then we jump to 16, and then we jump to 17, I guess, 18, 19, 20, 21, 22. And then we jump to this minimum here, which is somewhere there. Well, before we were here, so it's just a little bit different. Nevertheless, this is now a linear line, and just reset everything. And the step size, before the step size from here to was all the way there, like a big step. And now the step should be smaller. It is a little bit smaller. You go from minus 23 to that small step is now 3 or something, which is definitely not what it was before. Yeah, okay. So instead of from here going to there, we're now going from here to there, which is reasonable. And then everything goes wrong again because we still want to go left here. Left and right is nice, but I want to see the scale. Maybe I should draw another arrow which is just giving me the actual scale, so I can kind of check what happens, right? So I could put that one around the center of the left and right thing with the width of the scale value, which in this case should be a little bit less than this distance. Try this again. Yes. So for this scale, it would be interesting to know what the scale is here. So now we have the inflection point is more or less here. And that means that the right sample should be moved here. And then we have a weighted average around the critical point, which then is kind of equal to this distance, which I think this is minus 22, so let's say 8. That's probably correct, but you can have it printed somewhere, I think. Flop. That's 7.5. Not bad, not bad, not bad. I think it works. And we get 3.3. I'm not printing the reflection point here, otherwise I could have checked it with my calculator. Let's print them in this order. LCRI, which means CR, and then I. Okay, so here the left edge and the right edge do have neither a critical point nor the inflection point in between. Therefore, the result should just be the difference between the two. And I'm not going to type that in a calculator. Let's start BC. Where are my values? That minus that. Actually, the other way around. Okay, 2 point, yep, and that is correct. Then we go to the next one. And now we have minus 30 and minus 7, so the critical point is in between. And the inflection point is also in between. So I think we should get the weighted average between the difference between left. Can I do a square with this thing? Yep. So left. Say, where's my inflection point? Critical point. Inflection point is on the right of the critical point. So it is this value minus this value squared plus and this value minus inflection point value squared divided by good question. So just a bloody sum? Wait a minute. It's a sum, isn't it? No, it cannot be the sum. No, it's definitely not the sum. Well, actually, if one is negative... Oh, wait a minute. It's a difference. It's the sum of the differences. Yeah, but in a certain way. God, I have no clue. And I think even the sum of the absolute values. So in the end, I need something like, I think, inflection point minus that value. But 7. Great, just like an integer. Well, close enough. 7.57. Really? This thing does only integers? Ridiculous. Nah. Or did the square make it an integer? Do I have to do to the power 2.0 or something? 2 would be nice. No, I forgot something. Nope, doesn't want to do it. What the F is going on? Are you kidding me? Why is this rotating 7? What kind of bullshit is that? And still we have 7. Okay, give up in BC. Except, of course, that you can do settings. Oh, that's not BC. God. And that is in a dead tail. What do you get? 7.5759. Yep. Next. Now we have this one where it means that critical point is in between them and the inflection point also, again, very annoying. Yeah, did we already not do that one then? I mean, this is like an inflection point is on the, well, it's on the other side now. Okay, one more then. So I bet I'm getting now inflection point minus critical point. Inflection point minus the critical point squared plus, and then that would be the right thing minus the critical point squared divided by, and then I guess what is the right point. Let me think. Yeah, must be the right one. The right point minus the inflection point. I'm so good. Well, if it is correct, of course. And it's not correct because I forgot that thingy there. And now we have 3.31, which is, yes. Yeah, well. No, that's the same thing. 3, 2.9, 2.95, 3.05, 3.12. It is something interesting. First I have to jump to it. Now we don't have a thing anymore. Now we do. That's this case. We have now critical point here is not in between left and right, and the inflection point might be. Let's have a look. Minus 23, yeah, so just in between. So that'd be the last thing I test. It's hardly testable because it's only just in between. Why not? Let's test it. So that would be that minus that squared plus that. That's what I just typed. The other one then. Minus that squared divided by yeah, I'm still going for the minus sign. Probably this right minus left. And no, I did something wrong. Why did I use minus 38, which isn't even in the middle? I thought I had a case where it was just in the middle. Now I'm looking at something completely different here. Suddenly. It was here. Yeah. Okay. Choose this solution. This minus that squared plus that minus this squared divided by this minus that. Two 2.357. Close, but no cigar. No, that's not nice. That's not nice. I don't think we should have this difference, really. So is something wrong there now? I'm just going to add debug output for the calling the weighted average. And then I have to find back this point, well, the previous point even. This one. Surely we can find that back by highlighting this. Was that never happened before? There it is. Yeah, well, that looks good. It's the weighted average around the inflection point, which is in between. Yeah, I should go to bed too. I should go to bed. Or should I? It's always a question, isn't it? What I also should do is drink something. Drink more water. Yeah, this whole gradient descent is turning into a PhD, isn't it? Well, a PhD takes 4 years, but my God. It feels like writing a thesis, the amount of work. So it's kind of like the last year of a PhD. Very hard work. I'm just glad I don't have to write the thesis. Just doing the work is fun, but writing a thesis is absolutely no fun. Okay, so what is next? I'm still not convinced it works, but probably does. Yeah, I mean, the alternative would be that I made a mistake. Actually, not to laugh about. I seldom make mistakes, nor think about it. Now, this is shocking. What's going on here? It's only not printing the call to calculate value anymore. Is that because nothing changed or something? Is this the same value as the previous one? It is, but the values are different. They're not the same. What the hell? Oh yeah, sorry. I'm entering scale calculate value. But it's not returning. Oh, this is just a, sorry, this is just a difference. Yeah, I don't know, of course. Yeah. That's just the difference between the left and the right edge. That wouldn't print a weighted average score. You have another one. Yep, also correct. Okay, yeah, well, let's just stop because I think I fixed this scale part. And it's late enough to go to bed. Maybe commit this even. Let's lose a game of chess. Quit? How about quit? Exit and play chess. I'm just below 1900, like continuously. I'm really getting old. I mean, how old must you be if your rating of chess just starts dropping? But it dropped 100 points at least in like 1 year. So that doesn't predict a lot of good. No, does it? Okay, how do we punish this? There's not much to punish, is there? Why not just go here? So let's say I take, push, take. Ah, what? Why not? It's possible. It is possible. It looks like it is possible, therefore we do it. And now this one is attacked. Maybe he gives away the bishop pair. Go away. Gives it back. Does not give. Wow, that's interesting. I'm not really seeing it. Really seeing it. We attack here and moves the queen, of course. Queen goes here. I have to move again and go back. And then you could give a bishop, and then for 3 pawns basically. Tick. Oh, definitely looks scary, but I cannot imagine that this guy calculated it. I do have to go back though. Let me just go back. Now what? Show me. I'll probably miss something. So I'm threatening to take here, and then this whole idea of sacrificing here with an attack on the pawn. It doesn't do anything. This is an attack on the pawn as well, but I just go here and now it's defended again twice. So Okay, pins my auto defender. On the rook, which it just moved. Oh, not bad, not bad, not bad. So he could go here, and then he exchanges and takes there. And this is attacked. That's not nice. What about... What about... Yeah, nothing really. I just want to keep my pawn. Okay, let's complicate things. So it could double my pawn, but then give away the bishop here, give back the bishop here. It does not want to do that. Dude, it cannot be right, can it? Can't be right. Just keeps moving the bishops. Let's kick this bishop. True. Very true. Very true. But still, again, a bishop move. And now I have this one attacked. The only downside is that I wanted to go here with my queen. Yeah, I think it's possible. A check. So we go away, he takes here, and I take and he take, and I lose a pawn. Alternatively, I just go here, and I don't lose a pawn. I think not. Oh, no, I don't. Well, he could take here now and then. Well, this will work. I can even take like... No, I cannot take like that. So I take like that, he takes, I take with the queen. Yeah, that's not good. I have to take with the knight. Still a pawn up. The why not move? I don't know. It's a bit dubious, isn't it? A little bit. It's a little bit dubious. Yeah, I should have gone here, I think. I should have gone there, of course. Yeah, too late. So let's say I double and he takes and I take. I don't know if this works. Really don't know. Too late. Maybe that's not the best square. Should have gone here, threatening to go there. Would be way stronger. Can't go here now because of the queen. Can go just go that way. Well, I'm not against removing the pawns. Removing the pawns in front of the black king here. Oh, that is a possibility. Give check, he just takes it twice. And then I had to go with my queen here to pick up that one. It's not gonna happen. Nope, 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 nope. Okay then, let's go here. Yeah, that I didn't win anything here, did I? Anything. Rook takes. Right, it is not good. It's just attack 3 times. You have to go. How to go? It's not good. Okay. And resign, 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 resign. Wait. Wow, I didn't lose. Amazing, isn't it? Still under 1902. Okay. Good night.